All right, good afternoon, grade eights. I hope that you guys are all doing well and that you're having a productive Monday so far. We are back again, guys, for now the 13th lesson of the year with iRainbow. So I hope that you guys are ready to get going. We've got quite a lot of information to get through today, so I don't want to spend too much time talking now in the beginning and waiting for other people. Um, the lesson starts a lot fast, and unfortunately, today there's just a lot to do. So I sort of just want to hit the ground running. I want us to get started as soon as possible with today's work. Just a few things to mention very quickly before we dive into today's lesson. First things first, you guys might have recognized that we now also have the recordings, the live sessions for these tutoring sessions offered on Facebook and on YouTube now as well, right? Originally, we only had these lessons on Facebook, but we've now decided to extend that over onto Facebook as well so that it's even easier for you guys to access. So please remember that I'm now watching the comment boxes for both Facebook and YouTube, so it doesn't matter where you guys are watching from. Um, you can send a comment through the comment box, and then I will be able to read it and also answer it as well. Okay. So I would really appreciate it if you guys could quickly type your names into the comment box for me, and just let me know roughly who you are. Your first name is fine. It's just great for me to get to know you guys a little bit better so that I can become familiar with the people that choose to come every week. Um, but guys, we want to dive into a slightly new topic today. As I promised last week, we have some different work to attack, and that's because we've now pretty much wrapped up our discussions on the world or in the world of sequences. We've spoken about what sequences are, what patterns are, and we've gone into quite a lot of depth surrounding arithmetic and geometric sequences or patterns, which is what you guys to know about your tests and exams. Um, Keep in mind for me, please, guys, that today is the first time we are also hosting the grade 8 session live on YouTube. So all of the recordings for past lessons are still accessible on Facebook, but unfortunately only on Facebook. From today onwards, all of the lesson recordings are going to be available on both Facebook and on YouTube. Okay. So if you want to go back and watch any of those older lessons, just let me know and I'll try and give you the dates so that you can go back and find them. But today we want to tackle the world of algebraic equations, which I know is relatively new to some of you, and I want to get into some of the basics to make sure that you guys understand what we really mean when we're talking about an algebraic equation versus an algebraic expression, for example, right? What the words simplify or solve mean and how they're different when we use them, what we're supposed to do when we see them, so on and so forth. Um, you guys are going to be using algebraic equations until the end of matric, and if you decide to study further into any field that includes maths, well, you're going to continue with it then as well. So it's really important that we sort of get the basics right. So that's what we're going to start with. I'm not going to waste any more time. I'm just going to start streaming my screen. And you guys can write down today's date, which is the 14th of April. The heading is going to be Solving Algebraic Equations. Okay, let me just get my screen up as well. Um, you guys should be able to see my screen round about now. I'm scribbling in white, yellow, orange, and green pen. For those of you that are new, if you guys at some point during the lesson cannot hear what I'm saying or see what I'm writing, you need to please just put a message into the comment box for me so that I can then go and fix that. All right, because I want you guys to be able to see and hear everything consistently. So, you guys, like I said, should be able to see my screen. So you can write down today's date, like I said, and the heading is Solving Algebraic Equations. Okay. And we're going to start by just trying to understand some of the basics. Like I said, we need to know the difference between an algebraic expression and an algebraic equation because while you can solve an equation, you cannot solve an expression. So there's a few fundamentals that we need to just go through to make sure we're all on the same page, and then we're going to dive into today's work. All right, guys, I do want to give you a heads up. Depending on how far we make it in today's lesson, there is a chance that this is going to extend over two lessons. Okay, solving equations is by no means a small chapter um, in bird's eye view when we look at your syllabus. So we've got quite a lot of work to get through. So bear with me if I do end up moving too fast. Please just let me know, and I'll try and slow down. So you don't have to write what I'm about to write down in your notes. But if I have something, for example, like 2x plus 4 is equal to 8, how do we go about solving equations like this, grade eights? There's a few different ways that we can do it, and everybody tends to sort of develop their own sort of pattern or their own style of solving these things. Um, there are a few different ways, but regardless of which style you sort of choose to approach this with, there's always going to be certain things that hold true for all different styles. Okay. So I'm going to show you the way I recommend a lot of students solve equations. We're going to talk about how and why we do certain things and then go through some examples. Keep in mind that this is a very simple example of an equation, right? We obviously have the ability to step this up and make things a little bit more tricky, and we start adding all kinds of different elements to our um, equations, right? I'm not saying that this is going to yield any great answer, but this is just an example of uh, what you might need to solve when it comes to understanding your algebraic equations, right? If I'm asked to solve an equation like this, some of you might have a rough idea about how you would go about it. Some of you might be pretty confused and need a little bit of guidance. That's fine. That's what we're going to discuss today. So, first things first, we are talking about equations, grade eights. Please remember that you guys can type questions into the comment box whenever you have something you want to know a little bit more about. I'm watching both comment boxes, so please don't be afraid to type your questions into them. All right, let's start right at the very beginning and forget what we've just written down. Let's start by distinguishing between an algebraic equation and an algebraic expression. Okay, for those of you that don't know, an algebraic expression is a combination of mathematical terms that is not equal to a specific value. So, a an algebraic expression, guys, is a statement that usually needs to be simplified, right? So you need to start already understanding that the terms simplify and expression belong together, right? You can simplify an expression, but you cannot simplify an equation necessarily, right? You can simplify parts of an equation, but we instead talk about solving equations. So it's a statement that usually needs to be factorized and or simplified. You guys will have just started learning the basics of factorizing, so you should be roughly familiar with that term. So that's an algebraic expression, but that's not what we're focused on in today's lesson, right? We want to specifically talk about an algebraic equation. So if we had to define that in um, sort of more understandable terms than a lot of textbooks might put them into, what would we write down? An algebraic equation is a um, also a combination of mathematical terms that is set equal to some or other algebraic or some or other value, right? That can be algebraic. So it is made up of two expressions that are set equal to one another. So when we look at an equation, guys, you need to be able to find the left-hand side and the right-hand side of an equation, right? If you can't do that, the chances are you are not actually working with an algebraic equation. So if I were to give you something like 2x over 6 plus, let's say 18 over 9, and this is equal to x over 3. Just as an example, when we're given an equation, the goal is for us to find the value of the variable, right? So if we look at something like this, we can see that we have the variable x here. And so the goal of this entire process is for us to find the value that x is equal to. This is the process of solving, right? This is not simplifying, this is solving. So when you see your tests and exams, the teachers say solve for the value of x, y, or z. It means that you need to identify the unknown value that exists in that equation, right? And that can come in many different shapes and forms, and it can include fractions and decimals and all sorts, but we'll get to that. So the entire purpose of this lesson is for us to understand how we solve algebraic equations. And I want to write down a third point because this is going to answer that, right? We have two main processes that we usually like to follow when we go about solving an algebraic expression. So, um, we obviously know that we have four major operations: addition, subtraction, multiplication, and division. I know that we also have powers and root symbols as well, which we'll worry about at a later stage because that's not in the most basic form of equations. But when we talk about adding and subtracting, right, these are what we call additive inverses. Now, the reason why we need to know about additive inverses is because if I have something that is being added in an equation and I want to get rid of it, the way we do that is by subtracting, right? We know that adding and subtracting have opposite effects, which is why they are called additive inverses. So the same thing is true of multiplication and division. We call these our multiplicative inverses. And because these are the four major operations, when we're stuck in a question where we are needing to work with an equation and have to rearrange it to find specific values of variables, we want to make use of this understanding of additive and multiplicative inverses, right? And I'm going to show you what this looks like in an example now, but I want you guys to keep in mind that these are really beneficial, and without realizing it, They form the foundation of solving equations. So, without writing down too much information, we're going to dive into some examples. But even though this might not make perfect sense right now, I want you to remember that we always deal with our additive inverses first, and then we can move on to dealing with our multiplicative inverses. We always want to try and get rid of simple plussing and minusing, and then we deal with the more complex multiplying and dividing. Okay, so keep that in mind. Let's quickly go and take a look at an example. I'm going to quickly write one or two down and we'll go through them together. We'll stick with a very basic example for now. Let's say we have 2x plus 5 is equal to um, negative 3x plus 20. The question for these examples is going to be solved for the unknown value, solve for the value of the variable. You can word it how you like. So if I'm given 2x plus 5 is equal to negative 3x plus 20, let's just quickly get a game plan together for ourselves because that's really important. We need to first understand what it is that we're trying to do. And when we're solving an equation, like I said to you guys earlier, we are looking for the value of the missing variable, which in this case is x. Right? We are not looking for the value of 2x. We are not looking for the value of negative 3x. I want x on its own. So the way we like to do this is by collecting like terms, which you guys know a little bit about by now, right? We want to get all of our variables together and all of our constants together, all the normal numbers. So let's say I wanted to move this negative 3x over to this side because I wanted it to be with the 2x that I already have on the left, right? That would put my variables together. So how do we do that? If I have a minus 3x on this side, but I want it to appear on this side, how do I cancel out this effect? Well, if I have minus 3x, you can simply add on 3x, right? Because then these two would essentially cancel one another. But in order to avoid changing an equation, whatever you do to one side of the equation, you must also do to the other. So if I do plus 3x on the right-hand side of the equation, I must also do plus 3x on the left-hand side. So if we were to rewrite this step, we would have 2x plus 3x plus 5 is equal to positive 20, right? Keep in mind that these would now cancel, leaving me with just the positive 20 on its own. But now I really sort of want to get rid of this plus 5, right? Because we want that on the other side. So I can do exactly the same thing. If I can see over here that I am adding 5, to get rid of its effect, you would do the inverse. We would subtract 5. But what I do to one side of the equation, I always need to do to the other. So I would also now put a minus 5 on this side, right? So what would we have then, grade 8s? We would have 2x plus 3x. These 5s would cancel. And on the right hand side, I would have 20 minus 5, right? When we simplify the individual pieces, 2x plus 3x on the left hand side gives us 5x, and 20 minus 5 on the right hand side of the equation gives us 15, right? This makes things a whole lot simpler because now we understand that we have a lot less information to deal with. We've gotten rid of all of the silly plussing and minusing, so now we can focus in on our variables and the value that it's equal to. Now, if I'm looking for x on its own, what does that mean? I've got to get rid of this 5 that's attached to it, right? The 5 is currently in the way. So how would I get rid of that 5? Well, keep in mind that if I have 5x, that is the same as saying 5 times x, right? So right now, this 5 is being multiplied to the x. If I wanted to get rid of it, it means I would have to do the opposite. The opposite of multiplying would be to divide. So now, to get rid of that 5, I would divide by 5. But what I do to one side of the equation, you also have to do to the other, right? If we don't, it means we are changing the question, which we are not allowed to do, right? So what happens? On the left-hand side, these fives are going to cancel, leaving me with just x. And on the right-hand side, 15 divided by 5 gives me a value of 3. And so now I've gone and solved the equation and I've found that the variable x must have a value of positive 3. Okay, so guys, that is the long way of approaching a question so that you can solve for the value of a variable. Now, there are some shortcuts, and that's exactly what I want to show you guys. But this is exactly why I started by explaining additive and multiplicative inverses to you. Guys, when we are solving for a value, I cannot stress this enough. Maths is a game of manipulation, right? We haven't changed the question at all, but we are collecting things and changing the way they look and sort of reversing things on one side, but accounting for it on the other side. And so, after using a few different manipulation techniques, essentially, we're able to find our answer, right? And this is how we go about solving for the answer to a variable. So what I want to do now is show you guys the exact same question, but in a slightly different style, right? We're going to attack some more examples now, but I want to start with the same thing. 2x minus 5 is equal to negative 3x plus 20. And I want to show you guys the quote unquote shortcut method so that you guys have an understanding of maybe what your teacher is doing in class when they're moving a little bit faster. Okay? So again, we have 2x minus 5 is equal to negative 3x plus 20. Grade 8, the fastest way to get through an equation like this is to remember your opposites or your inverses, right? I know that I want to get all of my variables together and the constants together. So if I want to move this negative 3x over to this side of the equation, instead of doing this entire process we discussed on the left, the faster way to do it would be to simply change the sign, right? And we can do all of this moving in one simple step. So I'm going to leave this 2x that we have as is, but I want to move the minus 3x over to the left-hand side. All you need to do is change the minus sign into a plus sign. Then on the right-hand side, I have a 20, and I can take the negative 5. Sorry, this is supposed to be a positive, guys. I apologize for that. I can then take the positive 5 over to the right-hand side and it becomes a negative 5. And just like that, in one step, you've done what probably took us 3 steps to do in the slower version of this, right? 2x plus 3x is 5x, and 20 minus 5 is 15. Now, if we divide on the left, we divide on the right. Yeah? So I divide everything in the equation by 5, even if there were more terms. On the left, we are left with an x, and on the right, we are left with a 3. And so you can see that we achieve the same result, we get the same answer, but the the right-hand version of this calculation is not only faster, but you are prone to less mistakes. Okay, if you practice it enough. Obviously, if we don't practice, it's not going to work. Okay, now I just want to point out, pay attention to how we deal with all of the plussing and minusing first before we go and deal with the multiplication and division. Okay, I'm going to move down. I'm going to give you guys 1 minute to copy actually quickly. Then I'm going to move on to example number 2. And we're going to run through a few of them and then give you guys some examples to try on your own. All right. I haven't seen any questions just yet, guys, so I'm going to assume that everyone's all right for now. Please remember, these are some of the basics, and this is going to get harder next week, for example, right? I then don't have time to come back to this and re-explain the basics. So make sure if you have any questions, you ask me about them now. Let's talk about question number 3. Guys, if you need me to go back up, please ask. Let's say we had the following. 4x divided by 6 plus 4 is equal to, just give me a second quickly, guys. Okay, 4x over 6 plus 4 is equal to 2x plus 6. How do we go about an equation like this? I'm going to show you how to solve it, just like I will with the next 2 or 3 examples, and then it's time for you guys to try some on your own. First things first, when I look at all of this, I recognize that I need to solve, which means I want to get x on its own. We like dealing with fractions a little later on. So let's go ahead and move the 2x that we see over here over to this side here. All right. And on the right, for the constants, we'll move this plus 4 over to this side over here. So what are we going to have? Well, we keep the 4x over 6 on the left-hand side of the equation, but this 2x on the right becomes a minus 2x. This is then equal to the 6 that was originally on the right-hand side minus 4. Remember, because we want to change the signs. Now, we can't do much on the left-hand side over here because of this fraction at the moment, right? That's making things pretty irritating right now, but we're going to leave it as is. On the right-hand side, 6 minus 4 gives us 2. So as we go through these questions, we need to identify what the next most, how can I explain it? We need to sort of identify what the next biggest problem is, right? For us, in this case, it's going to be this 6 at the bottom. Now, if I wanted to get rid of something being divided by 6, the opposite effect would be to multiply by 6, right? So that's exactly what I'm going to do. I'm going to go through this entire equation and multiply every single term by 6. 4x over 6 times 6 means the 6's are going to cancel one another, right? So we're going to be left with 4x minus 2 times 6 gives us 12, so this becomes minus 12x equal to 2 times 6 gives us positive 12. All right, someone's asked to just see number 2. I'll go back up to it now so that you can finish copying. Okay, just let me finish this one. 4x minus 12x gives me negative 8x. And this is still equal to 12. So I've gone through the process of dealing with all of the plussing and minusing grade 8s. And now we reach this point at the bottom again where we want to get x on its own. So the negative 8 is in the way. So what are we going to do? The opposite of multiplying is to divide. So we are going to divide by negative 8 on both sides of the equation. On the left-hand side, the negative 8s are going to cancel, leaving us with just x. And 12 over negative 8 is something you can put into your calculator. You will see that it's going to be an answer of negative 3 halves, or negative 3 over 2. Okay? Just because you get an answer that is a fraction or because it is negative does not mean it is wrong. Okay. Quickly copy this, and then I'm going to go back up to number 2 so that someone can just quickly finish copying. If you guys have a question about example number 3, please make sure that you ask. If you guys do not practice this enough, grade 8, it's going to do two things. Number one, it's going to slow you down a lot in your tests, right? And as you guys are probably learning, you don't have that much time in a maths test to sit and figure things out. You really want to get simple things done as quickly as possible. And number two, if you don't practice this, even though you do know how to do it, um, when you're put under time pressure, you're much more likely to make silly mistakes. Okay. And that's going to reflect badly on you because then when you complete your tests and exams, you're going to be getting lower marks than you would expect. And it's all because of the time pressure. Right. I'm just going to move back up to number 2 so that somebody can finish copying. Okay. You've got 1 minute to quickly copy. Okay. Guys, let's go on to example number 4 now. If you guys have specific questions about these examples, please make sure that you ask. All right. Let's move on to number 4. Guys, I do apologize. The audio, as someone has pointed out, is not perfect at the moment. We're working to fix that as soon as we can. Okay, so hopefully by the time you're back next week, it'll be a whole lot better. All right. Let's take a look at example number 4, grade 8s. Now, remember, your teacher can also use a bunch of different variables. It doesn't always have to be the typical X, Y, and Z. They can switch it up as much as they like. So let's go through another example. Okay, here is the fourth example. Now remember, just like your teacher can test your understanding of your additive and multiplicative inverses, they can also test your understanding of things like this. where we need to use the distributive rule, right? Very important. Guys, these examples are going to get harder each time we do a new one, so please make sure you are just paying attention. So how would we solve something like this? Guys, remember, 90% of the time we are following BEDMAS, right? And P in BEDMAS, BODMAS, or PEDMAS, the B or the P stands for parentheses or brackets. So we need to start on the left-hand side by distributing into these brackets. 6 times 2y gives us 12y, and 6 times 3 is going to give us 18. On the right, it's kept fairly simple. We have 24 minus 6y, right? Again, you want to practice this process of moving elements around over the equal sign, but you need to keep in mind that you must change the sign. So on the left-hand side, we have 12y, and if we decide to bring the minus 6y over, it's going to become plus 6y. On the right-hand side, we had 24, but if we want to bring this positive 18 over to the same side as the 24, it must become a minus 18. 12, sorry, y plus 6y gives us 18y, and this is equal to 24 minus 18, which gives us the value of 6. In this case, we want y on its own, but right now it's being multiplied by 18. So we divide by 18 on both sides of the equation. Remember, even if there were more than just one term on either side of the equation, you would still divide everything by that value. So on the left-hand side, our 18s are going to cancel, leaving us with y. And on the right-hand side, we have 6 over 18, which is equal to 1/3. That will be your final answer. Now remember, if you guys want to double check your answers if you have time, let's say, for example, at the end of the lesson, you are sitting and going through your work, you can always take this answer that you got and substitute it into y's place, right? If we do that and put the full sum into our calculator, the left-hand side of the equation must be equal to the right-hand side. If they are not, it means that you've done something wrong. All right. I hope that that makes sense, guys. All right, I'm going to just give you a few seconds to copy, then we're going to move on. Now, guys, it should be no surprise that your teacher can also throw a few different variations of this work at you in your tests and exams. All right. Let's say, for example, we had something to do with foil. Okay, wait, sorry, just a second, guys. Right, if we're given something like this is a slightly different looking equation, but you'll see how your teacher has the ability to also work in things like FOIL, right? Which you might not expect when it comes to finding the answer to an equation, but it's a very real scenario that could exist. So let's take a look at number 5. You guys should be able to see it clearly. Over here, we have brackets and exponents at the same time, right? So when we think about head mass, bod mass, or bed mass, whichever one you work with, we know that we want to start with our brackets. So let's get going with this example. We know that when we have a bracket squared, it is the same as multiplying that bracket by itself. So x plus 2 squared is the same as x plus 2 times x plus 2. You can then write the remainder of this equation out because we haven't changed anything else just yet. Now, over here, we would want to use FOIL. We multiply the first terms, which gives us x squared. The outer terms is 2 times x, which is 2x. Then we do the inner terms. Again, 2 times x is 2x. And finally, 2 times 2, the last terms in the equation is going to give us plus 4. So that alone is what we get from expanding these two brackets, right? We can then write out the remainder of this equation because we'll deal with it in the next step. Don't try and do too much in one go. We see now that our x squared can cancel. 2x plus 2x, 2x plus 2x plus 4x gives us 8x, right? Plus 4 is equal to 10. That's a huge step for collecting like terms. I see that there was a question about the previous example. I'll answer it now. We can now take this over to the right-hand side. But remember, our sign needs to change. So on the left, we're going to have 8x. On the right, we're going to have 10 minus 4, which gives us 6. Okay? Now, it's very normal, guys, to get some answers that really aren't super great, like this one over here. Remember, we always want to get the variable on its own. Right now we have 8x and I just want x on its own, so we divide by 8. But whenever we divide in equation, we divide across the entire equation. Our 8's can cancel, leaving us x on the left-hand side, and 6 over 8 on the right-hand side can also be simplified to 3/4. Right? So this is a scenario in which your teachers will even put FOIL into your questions to see if you not only know how to do FOIL, but also know how to solve questions at the same time. So they're testing two different things in one question. And teachers love doing that because there's only so much they can fit into a 1 hour test or a 2 hour exam. Okay. Guys, there's 15 minutes left of today's lesson, and there's a lot more that we can obviously go through. And there's millions of different examples of equations that exist. Teachers are always trying to come up with new and wonderful ways to catch you and test you. So, unfortunately, I cannot go through all of them, but the goal of today's lesson is to set us up for more work that we want to also go through next week, right? Okay. Quickly copy down number 5. If you have any questions about number 5, please let me know. If you have any questions in general too, if there's something you want to know about the way I'm solving these equations, please, please, please ask. Okay. I just wanted to move over ever so slightly. Somebody asked about one of the steps here in my previous question, in number 4. They asked me over here, why is this minus 18? Okay, where does this minus 18 come from? To answer your question, it was originally plus 18 over here on the left-hand side, right? And when we move something over the equal sign, it needs to change sign. So a positive 18 when it was on the left must now change to a minus 18 on the right-hand side of the equation. All right. I hope that answers your question. If you're still confused, just let me know. All right. I'm going to move on to one or two last examples, guys, and then we are going to be done for today. So if you do have questions, please make sure you ask so that I can answer them before time is up today. Okay, I'm going to move on to number 6 very quickly. Right, let's say I have something like this. Hmm. Right. This is another example of just being able to use the distributive law, guys. Just before I move on to number 6, somebody asked about step 3 from question number 5. So remember, over here at the beginning of this step, we have to use FOIL, right? These two brackets gives us these answers over here, okay? But because we have a plus x squared over here on the left, and later on we also have a minus x squared, 1x squared minus 1x squared means that they are going to cancel, right? So we're no longer going to have any x squared terms. This 2x plus this 2x gives us 4x, plus this other 4x outside here can all be added together to give us 8x, right? And finally, that just left us with the plus 4, which we still kept on the left-hand side of the equation. The only thing that ever existed on the right-hand side was the 10, and that stayed the same for pretty much most of the question. So you can always take this a little bit more slowly and maybe use your own colors. But if you go through it slowly, you'll see that the x squareds cancel, and we can add these 3 different instances of x's together, right? Because they're all on the same side of the equation. So we can just plus them all together. They also all have plus signs in front of them, right? I hope that answers your question. If there's something that I didn't explain over here in step 3, please just let me know and I'll explain it just at the end of the lesson. All right. Guys, let's go through this last example over here. 6 times x plus 2 is equal to 8 times 2x plus 4. How would we go about solving this equation? Remember, solving means that we are working with the intention of finding the value of the variable. I've used x quite a lot today, but there's nothing wrong with that. So let's find the value of x in this case. What value can I put into x's place that will make this equation true? Or in other words, make sure that the left-hand side of this equation is equal to the right-hand side. On the left over here, remember, whenever we see a value right outside of a set of brackets like this, it means that we need to distribute because it is being multiplied by this entire bracket. So on both sides of the equation, we need to do a little bit of expanding. 6 times x is going to give us 6x, and 6 times positive 2 gives us positive 12. On the right-hand side, 8 times 2x gives us 16x. And 8 times positive 4 gives us 32. All right? Now, all we have to do is rearrange things. And remember, we can move things from the left to the right or from the right to the left by simply changing the sign if we are adding or subtracting. So, in this case, I maybe want to move my 6x over to this side, right? And that would mean I must move the 32 back over to the left. How are we going to do that? Well, if we want to move the 6x, it means we're going to have the 12 still on this side. But when we bring the positive 32 over the equal sign, it becomes a minus 32. All right? On the right-hand side, we already had 16x, but now we want to move 6x across. This is a positive 6x. So when it moves across, it must become a minus 6x, grade 8. Now, please remember, guys, just because I've decided to move my x's to the right and my constants to the left, it doesn't mean that you can't do this the other way around, right? If I wanted to collect the x's on the left and the constants on the right, I could do that too. There's nothing stopping you from doing that. As long as you're landing up with the same answer as me, then you are on the right track. So on the left-hand side, 12 minus 32 is going to give us negative 20. And on the right-hand side, 16x minus 6x will give us 10x. The whole point of solving equations, guys, is to find the value of the variable. I don't want 10x, I want x on its own. So to get rid of the 10 that is being multiplied to the x, I'm going to divide by 10. But what I do on one side of the equation, I must also do on the other side, right? So I divide by 10 on both sides. Negative 20 divided by 10 is going to give me negative 2. And on the right-hand side, the 10s are going to cancel, leaving me with just an x. Now, some people don't like leaving their answers written like this. So you may switch the sides of the equation, but keep them completely identical. So I keep the positive x on the one side and the negative 2 on the other side. And that is a completely legitimate mathematical switch you've done. Okay, you are allowed to do that. As long as you keep whatever you had on either side exactly the same, it'll be fine. All right. So, guys, I know that there are many, many, many examples of different algebraic equations that we could go through. And I wish I obviously did have some more time to talk about some of the more complicated ones with you guys. But the point of this lesson was to not show you necessarily how to solve the equations, but rather the approach that you can take, right? The stance or the view that you can look at these questions with so that it becomes easier to deal with. So, first things first, step A, you always follow, and I like to use PEDMAS, but you guys can refer to any acronym you prefer, right? You're always going to follow PEDMAS. Step 2, you want to deal with all of the adding and subtracting that you can, right? Add all of the like terms together, subtract any like terms from one another so that you can take out and remove as much repetitive work as possible. Step 3, you want to deal with all of your multiplying and dividing because this is usually one of the last steps that you want to do, right? This is not a perfect layout by any means for approaching a question, guys, but I think that it's helpful to understand that you usually want to get the simple things out of the way first, right? If we need to expand our brackets, start there. If you need to add and subtract like terms, deal with that next. And then as soon as everything is as condensed as it can be, should we move on to multiplying and dividing? If you start with your multiplying and dividing, guys, you're going to uh, complicate your work a lot more than you need to. Okay. You're going to end up in a position where you're just multiplying everything, dividing everything, and everything's becoming more and more tricky when the goal is to simplify everything that you can and condense it as much as possible, collecting all of the repetitive information so that then when you have to divide and multiply, you only have to do it to two or three terms, right? All right. So, guys, I hope that this was a relatively informative lesson on additive and multiplicative inverses. I hope that you guys found something that you can take away from the lesson, even if it's just a way that you want to approach these questions, because they are going to get more complicated. Now, you guys, I want to quickly take 2 minutes to hop onto iRainbow. I'm going to make it very quick because I know that we're actually officially out of time. But while I'm quickly changing screens, if you guys have got any questions for me about solving equations like this, please ask me. Okay, I'm more than happy to answer any of your questions, but I want to quickly show you iRainbow because there's a few quizzes that you can use on there to help you practice this work. Okay, so guys, you should be able to see my screen popping up on your screen now. And I have iRainbow up. It shouldn't look all that different from your iRainbow, right? Now, when you open it, you want to go ahead and immediately click on patterns, functions, and algebra, because this is the section that we are currently working in. We can then click on algebraic equations. Remember, there's a difference between an expression and an equation. So we're going to click on algebraic equations. Um, and you can go through any of these different quizzes, guys. There's a few that are examples of revision, and there's stuff like substitution that is also really important that I don't necessarily think is worth me spending time on, right? If it's something you guys want me to cover, then you're more than welcome to ask. But Right at the bottom, there's a quiz on solving equations by using additive and multiplicative inverses. When you open it up, you'll get a PDF just like you will with all of the other quizzes. Okay, and it's going to explain what I've done in class today in a little bit more detail, right? And it'll move a little bit more slowly, obviously, because you can go through it at whatever pace you please. But go through this document and make sure you understand it. Okay? And once you've done that, guys, once you reach the bottom of the document, you'll see that there's a video that's just short of half an hour long that I go through. This is a video that I've made for you guys that explains how algebraic equations work, right? I go into a little bit more detail than I have today to some degree, but it gives you a chance to go through everything very slowly if there's certain things that you weren't comfortable with in the lesson that we've just done. Okay, so consider going through this and then also doing the questions, guys. There's a few questions here that are pretty simple, but they're going to help you test whether or not you understand this enough for grade 8 level. All right. So go through them, submit your answers once you've calculated them on a piece of paper in front of you. Do not just try and do these sums in your head. All right. Do it on a piece of paper so that you practice the process of moving things over the equal sign, for example. Once you go through this entire quiz, it will give you a grade, right, which you'll be able to find under reports. You can ignore the ones I have here, but it'll show you the percentages you get for every single quiz that you guys do, and it'll just give you a better understanding of how much you really want to practice that specific section of work. Okay. So, guys, you obviously also have your textbooks. You now have iRainbow 2. You have PDFs, videos, quizzes. And I think that that's a lot of information for you guys to use to make sure that you thoroughly understand the topic of solving algebraic equations. Okay, there is a lot to it. I'm not going to lie and say to you guys that you should all understand it after one lesson. It is going to take a bit of time. You are going to have to practice. But using all of the resources that you have now in conjunction with one another should give you more than enough practice to make sure that you do understand it. Okay. Um, Grade 8s, we are already just a few minutes over time for today, so I'm sorry for that. Like I was saying, just as I finished the last example, I hope that you did get a little bit of value from today's lesson, whether it's got to do with a little bit of theory, maybe just understanding, or even just approaches that you want to take when you start with algebraic equations. Remember, the recording of today's session is now going to be available on Facebook, but also on YouTube. Okay. I think it's really cool that after, you know, a few weeks, you'll be able to go onto YouTube and watch all of our lessons back in case you need to revise for a test. I think it's a phenomenal resource to have, so I hope that you guys will use it. You can recommend it to friends if you want as well. But guys, our next lesson is going to be next week, Monday, again from 5:30 to 6:30 in the evening. I hope that you guys will join for that. We're slowly tackling more and more tricky topics. Obviously, it is just now the beginning of term 2 for many of you. So there's also going to be a lot that's going to be in your exams that we will be trying to revise. Okay. So if you guys have any questions, quickly type them into the comment box for me. But for those of you that understand everything and you're all happy, you guys are more than welcome to leave now. The lesson is over. I'll speak to you guys all again next week, Monday again from 5:30 to 6:30, and you can join either on Facebook or on YouTube. All right. Thank you so much, grade 8s. If you guys have any questions, I'm going to be here for an extra 1 or 2 minutes to answer them. But otherwise, I will see all of you hopefully again next week. All right. Thank you so much, grade 8s. Enjoy the rest of your evenings, guys. All right, guys, I haven't seen any specific questions from anyone. If you guys do find that you have questions, you're more than welcome to bring them along with you next week. You can ask me at the beginning of the lesson, and I'll do my best to obviously answer them. But yeah, it looks like time is going to be up for today, guys. So best of luck for the week ahead, and I will chat to all of you guys again in next week's lesson. All right. Thanks so much, grade eights. Enjoy, guys.